suppose say if we take example of Honda. So Honda is a two-wheeler manufacturer company, okay? And nearly you can think like, let's take an appropriate example, appropriate number, approximate number. Suppose a 3,50,000 motorcycles. It it is manufacturing, okay, and out of which it has made sales of 2 lakh motorcycles, okay. So I'm giving you an example that suppose say there is a company like Honda which is manufacturing two wheelers, and sorry, nearly sorry, yeah. So I was giving you an example like that there is a manufacturing company, say Honda, and Honda is manufacturing almost say 3,50,000 motorcycles in suppose say in a year, and there is sales of suppose say 2 lakh motorcycles, okay. Now in order to make that sale of 2 lakh motorcycles, it is expected to make certain number of cycles, certain number of motorcycles. If it is not making those motorcycles, how it is going to send it to its dealers, and those dealers are going to sell it, okay. So in order to make those motorcycles, Honda needs what? It needs sub assemblies which need to configure the match, the which need to configure the match, and it requires sub assemblies so that those required number of motorcycles can be made. The production of the required number of motorcycles can be made, okay. So it will require what? It will require some final assembly stations with some finite number of resources at each station in order to meet the targeted demand. Okay. So it requires what? It requires some kind of a control mechanism. It requires some kind of a scheduling activity in order to what? In order to meet the demand. Okay. Same way, if we take a very small example, suppose say I'm just taking a very random example. Suppose say there is a farmer, okay, and that farmer is manufacturing what? He is manufacturing, suppose say, potatoes, okay. Now he has, suppose say, some land, okay. Now he has to what? He has to ensure that he has 100 kg of potatoes. He is growing these. Okay, so this is the demand that he has to meet. So in order to meet this 100 kg of demand, he needs to do what? He needs to sow this sow the plant in such a way that after some fixed amount of time, like जो भी उस पोटैटो का ग्रोइंग पीरियड है, उसके बाद these potatoes are grown completely, and he is able to fulfill the demand of this 100 kg, okay. So whether it is your Honda ki manufacturing company, or if you take example of this, you require what? You require some kind of demand, and you need to supply that quantity which is demanded, okay. Or if you take example, you take another example, like there is a car, so Maruti has some sales target of suppose 4,50,000 cars. So if it has got this target, Maruti needs to do what? It needs ensure the raw materials to its all the assemblies, and these sub assemblies need to be provided with the raw materials so that they can produce the finished output. Okay, so adequate, you want adequate raw material needs to be what? Adequate raw material needs to be provided into this assembly line. Okay, now what is line balancing? So first of all, let's understand what is line balancing. Line balancing is basically, line balancing is a method which you are doing what? You're optimizing the task without violating any constraints on the workstation. Okay, what are constraints? Like, you people know what is constraint. I hope you people know what is a constraint. Like constraints, you people know what are constraints. I hope I'm getting what I'm saying.
I'm
Am I
constraints
audible?
you. Yes, ma'am.
Yeah,
Yes,
constraints,
ma'am.
yes. You know now what are constraints. Like constraints are basically what? Constraints are the limiting factors. Okay. Like if suppose say you are into shirt manufacturing business. Okay. So you have to manufacture some shirts. Okay. So if suppose say there is some shirt manufacturing company. So for that shirt manufacturing company, you have seen that what you need to do. You have to manufacture shirts. There is some demand of shirts. Suppose say 100 shirts you need to manufacture. So this 100 is what? It is the demanded quantity. Okay. Now you, for manufacturing those 100 shirts, starting of what you require some kind of buttons, you require some threads, then there is some sewing machines. These are what? These are your now there is some limiting factor. Okay. Constraints are your limiting factors. Like factor, that limiting factor is that the labor is only available for your suppose say 8 hours a day.
Ma'am, sorry to interrupt. I'm sorry to interrupt, but your screen is not visible.
Labor work more than 8 hours a day. So this is a constraint. Okay. Then you have yes. What?
I'm sorry to interrupt, but your screen is not
Yes,
visible.
ma'am, your voice is also lagging a bit.
Yes, ma'am.
Okay, I'll just check. I'll just check the connection.
Yes, I'm rejoining might help.
Now is it fine?
Yes, ma'am, it's fine.
Okay, fine. So constraint, I was explaining you about the constraint. Okay. Constraint is basically what? Constraint is a limiting factor. Okay. Constraint is what? Constraint is a limiting factor in the in your entire production system. Okay. So what is in layout in this line balancing, what we are doing is that we are trying to we are trying to, in line balancing, what we are doing is that it is a method by which we are trying to optimize the task without violating any precedence constraints in certain number of workstations which are designed to complete the task. Okay, so like I gave you the example of that, uh, of this car one. So these are basically what, these are your workstations. Okay, this is your workstation, this is your workstation, this is another workstation. Okay, and these workstations, these are doing some kind of task, you are doing some kind of a task on this workstation. Okay, so through the help of line balancing, what we are trying to do is we are trying to meet the production rate, the required production rate. Okay, in order to we are trying to meet the required production rate with the minimum number of resources which are required. Okay, we are trying to use the resources optimally in order to meet the production rate which is required. Okay, so first of all, let's understand what is line balancing. Okay, so line balancing is basically what? Line balancing is a method it is a method by which tasks are optimally combined without violating precedence constraints. Without violating the precedence constraints, and certain number of workstations are combined to complete the task. Okay, and certain number of workstations are required to complete the task. Okay, so this is what, this is line balancing. Okay, now in line balancing, suppose say there are three workstations A, B, C, and out of those A, B, C, seven tasks are performed in any manufacturing system. Okay, so what will be the workstations will be denoted as how? Workstation, suppose there are three workstation. So workstation will be denoted as workstation A, workstation B, workstation C. So these are your three workstations. Workstation A, this is your workstation B, and this is your workstation C. Okay. And these workstations are performing what? These are performing some kind of tasks. The number of tasks is given to you as 7. Okay. Fine. So each task will be provided with what? It will be provided with some kind of a time. Okay, that is known as basically what? That is known as your cycle time. Okay, so each workstation is what? It is provided with a time which is known as a cycle time. Cycle time is basically what? The time to uh, to complete the production. Okay, the time that is required by the workstation to complete the production. Okay, fine. And the maximum of these workstation will be what? There will be, like, suppose say workstation A requires 5 seconds to complete the task. Okay, so in case of workstation, the time will be what? It will be 5 seconds. B requires 4 seconds. C requires 3 seconds. So these will be what? These will be your time which is required to complete the task. Okay, fine. So this is about the time that is you are required to the time the each workstation, the time which is required by each and every workstation to complete the given task. Okay, I hope till now it is clear. No one is having any doubt.
Ma'am, what was time equals to 7?
Time it was not time, it was not time, it was here you were saying it was task.
Okay, okay.
Task. Okay, it was not time. Time is this 5 second, 4 second, 3 second. Like you can take an example. Suppose say there is a there is, suppose say we take that example of shirt wala. Let's suppose say we have to make shirts. So in case of shirts, a shirt goes through three workstation: workstation A, workstation B, and workstation C. Okay. So suppose say in this workstation it requires 10 minutes in cutting of the shirt, then uh, you can say 7 minutes in sewing of the shirt, and 5 minutes in packaging. Okay, so this is your workstation A. This is your task 1, this is your task 2, and this is your task 3. And this entire is basically what? This is your entire complete line. This is your complete line of production. Okay, so this is your complete line of production. Fine. So I think through this example now this time and all you would be clear to you. I think now this is clear. Okay.
Ma'am, what's the relevance of precedence constraints?
Precedence constraints, I will tell you what are precedence constraints and all. Constraints, like suppose say you have this type, like there is this constraint that you have maximum of 11 minutes for cutting. Not more than 11 minutes should be used for cutting. Okay, so this is my limiting factor. Okay, like if you have you people studied that linear programming problems, I think in 12th you would have studied linear programming problems. So
Yes,
in
ma'am.
those you have some kinds of like constraints are given to you. Constraints are basically what? Constraints are your limiting factors. Like in case of this in case of this shirt manufacturing, one constraint can be that you cannot use more than 40 meters cloth. So this is one type of a constraint. So cloth ka constraint hai that you can't use more than 40. Okay, so this is one constraint. Then for sewing you can't use more than 11 minutes. So this is again a constraint. So in this task, sewing task, you can't use time more than 11 minutes. Okay, so this is a constraint. This is a second constraint. For suppose say cutting, you can't use more than 15 minutes. So again, this is a constraint that cutting should be done with less than 15 minutes, less than equals to 15 minutes. So this is another constraint. So whenever we are designing our task, whenever we are balancing our assembly line, we need to keep in mind that we are not violating these constraints, we are not violating these limiting factors. We have to design the assembly line in such a way that we are able to what? We are able to fulfill each and every task without limiting, without violating any of the constraints. Okay, fine. So in assembly line what happens is that in case of your assembly lines, the machines are placed the machines are placed or arranged in a sequential manner of operations needed for production. Okay. So in case of your assembly line, your machines are arranged in a sequential manner of operations needed for production. And assembly line is what? Assembly line aims to assign all the tasks to a series of workstation series of workstations so that all the workstations are synchronized synchronized, and their ideal time is minimized. Okay. Now, whenever we are dealing with assembly line balancing, there are some important terms that we need to understand first. Okay. So, what are these important terms? These important terms are, first of all, is the cycle time. Okay. Cycle time is also known as your takt time. Okay. Cycle time is what? Basically the time between units coming off to an end in the assembly line. Okay. Or you can say the maximum time allowed for each workstation to complete the task. Okay. So cycle time is basically what? The time between units coming off to the end of an assembly line. Okay. Or you can say, or cycle time refers to maximum time allowed at each workstation. So like I gave you that example, like there are three workstation A, there is workstation B, and there is workstation C. And maximum time allowed at workstation A is 10 minutes, B is 7 minutes, and C is 5 minutes. So this 5, 10, 15, what are these? These are your cycle times. Okay, fine. So the next term is your task. Okay. Next, next is your task. Task basically refers to what? Task is the smallest element of work. Okay. So it is the smallest element of work. Okay. This is your task. Okay. And next is your task time. Task time is the time needed to complete one unit of task. Okay, this is your task time. ठीक है. So these are your three important, you can say, the terms in your assembly line balancing. Okay. Now let's discuss the steps in assembly line balancing. Okay. So steps in assembly line balancing.
Ma'am, the cycle time of one workstation can be bifurcated into different task time, right?
Yes. I'll give you one example also using I will explain you one example, then I think you will get to understand each and everything. We'll do one example, then all your doubts will be cleared.
Right.
Okay. So what are the steps in assembly line balancing? First of all, we need to draw a precedence diagram. Now this is very important because in your previous year questions, previous year exams, this drawing of precedence diagram has come in exams. Okay, so we will do practice of this questions. So first of all, we need to draw precedence diagram. Okay.
And are these similar to the ones that we are drawing in QT, quantitative techniques?
QT and the, like, what methods you are studying?
Maybe
Ma'am, AOA.
yes, ma'am.
Okay. Might be like in precedence diagram is like precedence diagram ke andar what we basically do is you have some kind of tasks are given and you have to arrange those tasks according to the, I'll give you the example, then might be you will see it ki, like, if you are have you studied PERT and CPM?
Ma'am, we have done CPM and we will be doing PERT.
Then you will be able to relate it with that. Then you will be able to relate it. CPM and PERT say you will be able to relate it.
Okay, ma'am.
So you need to draw a precedence diagram. This is important because it has been asked in your previous year questions. Precedence diagram you need to draw. Okay. Then after you have drawn your precedence diagram, you have to find the cycle time. Okay. Find the cycle time. So cycle time, how do we calculate? Cycle time we calculate is cycle time is equal to your production upon the total production upon number of units. Okay. Okay. So this is your cycle time. Okay. So time divided by the number of units. Okay. Then after this, what we need to do is, after finding the cycle time, we need to find the number of workstation. So how do we calculate the number of workstations? Minimum number of workstations. So this is sum of tasks sum of task time by the cycle time. Then you need to use the, like, which rule you are using. So here we are balancing the assembly line using balance the assembly line using LOT rule. LOT rule is basically what? LOT rule is your longest operating time. Longest operating time. Okay. That is basically we are assigning that task which has longest operating time. Okay. Then after this, we will determine the efficiencies, and we will rebalance if required. Rebalance assembly line if required. Okay, fine. So these are your 6 steps in assembly line balancing using longest operating time. Okay. So now if uh, now there are some other formulas. There are three more formulas. I'll give it to you, which are useful for solving numericals for your exam. Okay. So these are what? One is your actual cycle time. Actual cycle time. So actual cycle time is equal to your available time by your actual production. This is one. Then you have another, that is your number of workstation. So I have already given sum of all tasks by cycle time. Number of workstations. Minimum number of workstation. Minimum number of workstation is sum of all tasks divided by the cycle time. Okay. Sum of all tasks by cycle time. And average resource utilization. Average resource utilization. This is the third formula. Average resource utilization. This is sum of all tasks by number of workstation into cycle time. So these are your three formulas which are important for your solving of numericals. Okay. Now I'm giving you one question. Let me just see if this question can be pasted in your this. On your Jamboard. Just let me just see if it can be pasted. You just take a snapshot of these formulas, then I'll see if it can be pasted.
Can you show the last?
Yeah, I'll just move it. If you have taken the snapshot, then just let me know. Then we will
Yes,
discuss.
ma'am.
Okay. Now I'm sharing the question on the next slide. Yeah. I hope question is visible I'm just increasing the size.
Yes, ma'am.
So a factory is working in two shifts of 8 hours, produces 24,000 electric bulbs using a set of workstation. Using the information, compute the actual cycle time of the plant operation. First of all, you need to compute this. Okay. Then there are 8 tasks required to manufacture the bulb. The sum of all tasks equals to 12 seconds. How many workstations are required to maintain this level of production, assuming that combining of tasks into those workstation is a feasible alternative. So this is the question. You have to calculate. What do you have to calculate? You have to calculate the actual. You have to calculate the actual. First of all, you need to calculate the cycle time. First of all, you have to calculate the actual cycle time, and then you need to calculate the number of workstations which are required. Formulas for the questions are there with you. The formula which is required is given to you. Next class mein we will discuss how to draw precedence diagrams, how to draw. Next class mein we will do a complete full-fledged question. I'll take up a previous year question only, and I will discuss a full-fledged question. How to draw precedence diagram, and all the 6 steps that we have discussed of assembly line balancing, we will apply those. This question I have done because it is easy, you people can calculate it. In this you have to just calculate the cycle time, and you have to calculate the number of workstations which are required.
What is the number of workstation? 5.
Number of workstations are 5, yes.
Okay, ma'am.
And that cycle time,
Now it's 12 by 5.
12 by 5.
To 2.4 basically.
Yeah, 2.4. ठीक है, ठीक है. 2.4 is correct. So how have you done?
Basically 16 hours को divide कर दिया by 24,000.
Yes.
So I got 12 seconds, 5 bulbs in 12 seconds.
Hmm.
Then divided 12 seconds, which was then calculated the number of workstation, which was the total time taken 12 seconds
Hmm.
divided by 12 by 5. So
Hmm.
I got 5 as the answer.
Okay. ठीक है. What about others? Are you doing, or what about others?
Done, ma'am.
Okay. So now I'm discussing the answer for those who are unable to do the question. So basically, what this question is saying is that there is a factory which is working in two shifts of 8 hours, and it is producing how many bulbs? 24,000 electric bulbs, okay, using some set of workstations. And now, first of all, using this, you have to compute the actual cycle time of the plant operation. And there are 8 tasks which are required to manufacture the bulb, okay. So first of all, we need to do what? We need to convert this 8 this 8 hours into, first of all I'll convert it into seconds. Okay, so how I will do is, first of all I will see the actual production. So actual production is my 24,000, this 24,000 bulbs. Now what we are doing is that there are two shifts of 8 hours. Okay, for two shifts of 8 hours we have to find out the time, the available time that we have. So available time will be what? One shift is of,
16 hours.
yeah, 16 hours. So I am converting that 16 hours into seconds. So I'm basically multiplying it by 3600. Okay. So 16 into 3600. 16 into 3600 will be what? 57,600 hours. Okay. So it will be, sorry, 57,600 seconds, not hours. I have converted it into seconds. Okay. If you are not multiplying it by 8, then it will be, actual time will be what? 12 into 8, which will be 16 hours. Okay. But I have converted it into seconds. Okay. Now, cycle time is what? Cycle time is your, cycle time is
Available, available.
available time upon
Yes,
the production.
yes, ma'am.
So available time upon the production, upon production. So the students who have not converted it into that hours, उनके लिए it will be coming out to be as 16 upon 24,000, ऐसे जिन्होंने hours में ही रखा है. The students who have not converted into hours, for them it will be this value. And if you are converting it into hours, if you are converting it into hours, so it will be,
Ma'am, it's already in hours.
if, yeah, if, sorry, if you are converting it into seconds, so it will be this. Yeah, for this will be in seconds. And जिन्होंने hours में करा, it will be 16 hours divided by 24,000 bulbs. Okay. So I think this is giving you what? It is giving you 2.4 second. Okay. So this is giving you 2.4 second, which means that the factory is producing one bulb in every 2.4 second. Okay. So this is what? This is your 2.4 second. Okay. Now what we need to calculate? We need to calculate the number of workstations. So what is the formula of number of workstations required?
Sum of all tasks divided by cycle time.
Yes. The number of workstation is your sum of
8.
all task divided by the by the cycle time. Yeah. So what will be the sum of all tasks?
8 divided by 2.4.
8 divided by 2.4.
Ma'am, 12 actually.
12. Yeah, it will be 12. Fine. Sum of all tasks maybe आएगा, it will be 12 divided by 2.4. Cycle time was 2.4 because, so it was what? It is coming out to be 5. ठीक है. So number of workstations that we require is what? 5. Fine. So this is the answer.
Ma'am, in the average resource realization formula, what's the numerator?
Average resource utilization, sum of all tasks only. Sum of all task times only. I think मैंने वो लिखा है ना?
I think it's only a sum of tasks.
Okay, I'll just sum of all tasks.
So how do we calculate the sum of all tasks?
Sum of all tasks we calculate using, In this, what we will be doing is sum of all tasks will be based upon what? The एक मिनट रुको, मैं बता रही हूँ. सम ऑफ ऑल टास्क टाइम्स है इसका न्यूमरेटर जो है. ठीक है, द न्यूमरेटर इज सम ऑफ ऑल टास्क टाइम. सम ऑफ ऑल टास्क टाइम विल बी व्हाट? इट विल बी दी
Comments given on 12 seconds.
या इट इज ऑलरेडी गिवन. सम ऑफ ऑल टास्क टाइम, इसको यहाँ पे लिख देती हूँ. सम ऑफ ऑल टास्क टाइम, सम ऑफ ऑल टास्क टाइम. Here also, I think it's given a sum of all task times is equals to 12 seconds. Yes.
Ma'am, so same will be for average resource utilization.
Yes.
Numerator
No,
is,
no, no, no. But उसके इसके नीचे your denominator
ma'am,
changes.
about numerator only, sir.
हाँ, numerator is same, but denominator changes in case of average resource utilization. Here, in case of denominator, you multiply cycle time with the number of workstations. So if you calculate the average resource utilization for this question, what it will be? Sum of all task times, which is 12, divided by number of workstations is 5, and cycle time is 2.4 seconds. हाँ, so इसका calculate करके निकाल लेते हैं.
And 1 hour.
हाँ, yes, because उसमें यही होगा ना, sum of all task is 12 और उसको हमने 5 और 2.4 कर दिया. 5 and 2.4 is what? 12 only. So it is average utilization will be 1.
Ma'am, average resource utilization तो हमेशा 1 ही आएगा ऐसे.
नहीं, it depends कि मतलब
Ma'am, because if we
क्वेश्चन में अगर सम ऑफ वर्क जिसमें सम ऑफ ऑल टास्क अगर कुछ और गिवन है, इसमें तो वो 12 है, तो इसीलिए
नहीं
तुम्हारा
नहीं
1 आ रहा
मैम,
है.
मैम अगर हम वेरिएबल्स की टर्म्स में ही फॉर्मूला को एक्सपैंड करेंगे, नंबर ऑफ वर्क स्टेशन के बजाय हम सम ऑफ ऑल टास्क अपॉन साइकिल
एक
टाइम लिख
मिनट एक
देंगे.
मिनट एक मिनट एक मिनट, इधर ही करते हैं.
नंबर ऑफ वर्क स्टेशन के बजाय अगर हम सम ऑफ ऑल टास्क अपॉन साइकिल टाइम लिख देंगे तो एवरीथिंग विल कैंसल आउट एंड इट विल
हाँ
बी
हाँ हाँ, यस 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 यस, बिकॉज इट विल कैंसिल आउट. मिनिमम नंबर ऑफ वर्क स्टेशन से ये कैंसिल आउट हो जाएगा, सम ऑफ ऑल टास्क और साइकिल टाइम. सो इट विल बी इक्वल टू 1 ओनली. यस.
Ma'am, so what's the utility of this formula?
यस मैम.
Of this average resource utilization.
Yes, ma'am.
Basically, if we like, I'll tell you. So if we are designing, if we are trying to find out like the trade-off issue between the inner assembly line, okay. So what we are trying to do is like we are trying to like using this formula, we are trying to optimize our this entire assembly line, okay, and we are trying to balance off our entire assembly line, okay. So the production rate, the cycle time, and the number of workstations, they are what? These are interrelated with each other, okay. And the number of workstation is basically what? The number of workstation is what it is. It has a, it has, you can say, it has a bearing on the average resource utilization, okay. And because of this, there is what there, you can say that there is a uh, interrelationship between all the three items, okay. So इनका use क्या है? इनका use is to identify, to optimize your entire assembly line, to balance out your assembly line. Fine. ठीक है. इसको we'll take up in detail in next class. थोड़ा सा और we will take up in detail in the next class, okay. And then in next class we will try to, we will do a complete problem of assembly line balancing using longest operating task time, okay. So say you people will be able to like able to understand in a better way. Or should I give you a question for homework? Should I give you a question for homework, or you
I
want?
think we've already given one. We will do it.
Yeah, so okay, ठीक है. First you do that one, then we will take up other questions. Okay. इसको we will take up 2-3 questions of these types, and I will also take up few your previous exam year questions, previous year's questions, which have already been asked in your exam, so that you people can get a practice of it. This topic is the formulas are very very simple, and the numericals also which come from this topic, they are very easy. Directly you have to put the formulas in your answer, and you have to put the values in your answer, and your formula, it will give you the answer. So it's very easy. So I'm stopping over here. In next class we will continue from here. Okay. So one question I have already given you. You complete that first, and then in next class we will complete this assembly line balancing using longest operating time.